We are given two functions, fx, which is a quadratic, for x greater than or equals 2, and gx, which is linear for all real x. Part A states the range of f. Fx is a quadratic in the form of x minus 2 squared minus 4 for x greater than or equals 2. From the quadratic function, we can see that this is a function, a quadratic that opens up. And then the vertex here is given by 2 and minus 4. So that is the vertex. But this fx is only defined for x greater than or equals 2. So we are only looking at this part of the function, where x is greater than or equals 2. And we can see that the y values, the minimum y value is -4, and y is greater than or equals -4 for this part of the function where f is defined. So the range of f is from -4 through infinity. That gives us the range of f. Part B, we need to find the inverse of f. To find the inverse of f, we set y equals fx. So y is the square of x minus 2 minus 4. We interchange x and y. X is the square of y minus 2 minus 4, or x plus 4 equals y minus 2 squared. We can say that the square of y minus 2 is x plus 4. Taking square root, y minus 2 is the positive and negative square root of x plus 4. And then rearranging, we can move -2 over so that y is 2 plus minus square root of x plus 4. The function fx is only defined for x greater than or equals 2, meaning that this value, y value for inverse, must be greater than or equals 2. Here 2 plus a non-negative number and 2 minus a non-negative number. For each to be greater than or equals 2, this y must be greater than or equals 2. We only take the positive part. So we say that the inverse of f is 2 plus square root of x plus 4. This will give you a value that is greater than or equals to 2. Part C, given that a is minus 5 over 3, if a is minus 5 over 3, then g of x is minus 5 over 3x plus 2. We need to solve the equation that fx equals gx, so that x minus 2 squared minus 4 equals minus 5 over 3x plus 2. Expanding x minus 2 squared, we have x squared minus 4x plus 4 minus 4 equals minus 5 over 3x plus 2. The plus 4 minus 4, these will cancel. And to eliminate that 3, we can multiply the equation throughout by 3, so that 3x squared minus 12x equals minus 5x plus 6. Rearranging the equation by moving everything over to the left, we have 3x squared minus 12x plus 5x. We have negative 7x minus 6 equals 0. This trinomial can be factored to 3x plus 2 and x minus 3 equals 0. Setting each part to 0, when we set 3x plus 2 to 0, we have x equals -2/3. And when we set x minus 3 to 0, we have x equals 3. This equation, fx equals gx, is solvable, has solution in the domain of f. That is, x must be greater than or equals 2. The only solution where x is greater than or equals 2 is the value of x equals 3. This is not possible. So this is not a solution. The only solution that we have is x equals 3. -2/3 is not greater than or equals 2. Part D, we are given that g of f inverse 12 equals 62, and we need to find the possible value of a. So we need to work out the left side. To work out the left side, let's find f inverse of 12 first. F inverse is 2 plus square root of 4 plus x. So we have 2 plus square root of 12 plus 4, which is 2 plus square root of 16. Square root of 16 is 4. 4 plus 2 is 6. Then we find g of f inverse of 12, so that g of x is ax plus 2. This will give us g of 6, and we have 6a plus 2. Now g of f inverse 12, that will give us g of 6a plus 2. Then from gx here, we have a. We replace x with 6a plus 2, and that will give us 6a squared plus 2a plus 2. Now we are given that g of f inverse 12 equals 62, meaning that this part must equal 62, so that 6a squared plus 2a plus 2 equals 62. We can divide throughout by 2. 3a squared plus a plus 1 equals 31. Making the right side 0, we bring the 31 over to the left. 3a squared plus a minus 30 equals 0. And we can factor the trinomial to be 3a plus 10 times a minus 3. From here, when we set 3a plus 10 to 0, a is -10/3. And when we set a minus 3 to 0, a equals 3. So these two forms the solution.